unified over all window release. I mean, each release has different implementation. Same command will work, but it's not implemented the same way. It's totally different. It's actually more than 26 years old. It was developed by IBM. The first documentation found was like the oldest. It's dated from 84, which is pretty old. It seems to be safe, but it's seriously poorly audited. As protocol, fuzzing is pretty fast, and a lot of Linux distribution is using SMB. So for the approach, I use two-step methodology, which is normal fuzzing methodology. I mean, there's nothing new in that. It's totally normal. Which is research RFC books like implementing CIFS from the Samba team, and some MS specification. Documentation takes always most of the time of the fuzzing process. I mean, it's sure that you can just capture some packet and fuzz, but I mean, you won't find anything. It's pretty clear. So my approach on this case, I build a lab with some laptops now that I'm traveling a lot. So with some laptops and some VM, just trying to use retrocompatibility. So basically, I will install from Windows 3.1 for work groups to Windows 7, Samba, US2, and other type of clients like Mount CIFS, and this type of implementation, LAN client also. You can also set an Active Directory environment in the lab with some specific version of Windows join, like 80, 88, 24, 87, this stuff. Capture the communication between this version and build a PKIP database. So basically, we will try some communication, access shares and stuff between Windows 94 to Windows 2008, initiate the connection, capture this connection, do exactly the same on the reverse, and so on and so forth. Basically, my database is about 1 gigabyte, and I use it. I built some plugin for my server to use directly the ticket file. So basically, when you join your computer on Active Directory service, the communication will be shared. They will be different. You will be, first of all, in the domain, so really you will use some other fields that on normal communication between the client and the server wouldn't be there. The more difference you get, the more chance you can you have a chance to trigger some funny bugs. Targeting the retrocompatibility is totally a key in SMB fuzzing. So basically, targeting whole functions that are still supported between window versions. I think it's totally a good idea, and so far it's been pretty successful. Because when capturing some conversation between Windows 95 and Windows 7, fuzzing this conversation can be pretty good actually, because you will, as I say, target whole functions that are not so well looked. Never use a framework library. There's a bunch of library around, SMB. Just, I think everyone tried that before. Like anyone who tried to fuzz SMB before, just try some library or framework. Didn't work, I guess. So basically, you got to build your own client, make sure that it's working perfectly with Wireshark, and then when it's built, you can build a targeted fuzzing library, which for you will update frequently. I start with 3 functions at the beginning, and I'm around 40 functions now, which are all different and are typically adapted for SMB fuzzing. I won't be able to use that library for any other type of fuzzing. Anyway, good thing is also to fuzz independently each host, because each implementation are different. They are totally different. I found some bugs only on Vista, on SMB v1, only on Vista. I found some bugs on Windows 7, only on Windows 7. SMB v1 implementation, only on XP. So it's always better if you have a bunch of machines, preferably physical. Sometimes VMware does some weird stuff and can reproduce some bug on VMware with guests on VMware. So if you have the machine, it's probably better to do it on physical machine. Do a first round fuzzing, which is called basically dumb fuzzing. So basically you throw whatever. You don't go structured. You don't care about BCC. You don't care about any field. You just take a packet and you modify it. It's just the first round of fuzzing, just to capture the dummiest bugs around. For each function, upcast of functions, so for example, trans2 request will have 6 or 7 opcodes, which is all different, and targeting one function at a time, because with all the functions that you use in the communication, you better fuzz one function at a time, because if not, the fuzzer will run forever. The target function packets are usually small. With the fuzz thing, actually, my fuzzer is coded in Python. It's about 30 packets per second on SMB. It's going actually at the speed of the server. 4 minutes per function is more than enough. I mean, I heard a lot of people saying, yeah, but you know, if you fuzz, basically the machine is working for you. So I just start my fuzzer and I come back in 20 days, or